Hey, sixth graders, we are on lesson 4, session 2. This starts on page 69. And be sure you've done lesson 4, session 1 before beginning it. You're going to need to have done all that vocabulary and exploration before you're going to be able to comprehend this develop lesson, which is writing and interpreting algebraic expressions. So we're not solving them today. We are writing algebraic expressions and we are interpreting them. That means we are using variables today. And our try it question involves tamales. I'm excited. I'm sad because I don't really have tamales. That would make me excited. But the Ramirez family is making tamales. They wrap the tamales in corn husks for baking. They have 8 corn husks, so we know how many they have. Isabel is bringing 3 bags of corn husks. And each bag has the same number, but does it tell us what number? No. How many corn husks do we have? So we're going to use, how can you use an algebraic expression to show the total number of corn husks? So we're going to draw this. I'm going to draw some corn husks. We have 8, so 1, 2, 3, 4, 5, 6, 7, 8. We have 8 husks. And then we have, how many bags is Isabel bringing? She's bringing 3. And these are each a bag. So, and we don't know how many are in it. So what variable do we want to use to represent the unknown amount of husks? So we've got H husks. Because we don't know. So we can't put a number of husks per bag because we don't know. So we're going to use H instead. You could use X if you wanted. That's the more traditional one. Doesn't really matter. So we have, for our number of husks, we have 8 plus whatever H is plus whatever H is plus, that should be a plus whatever H is. That's how many we have. How many H's do we have? 1, 2, 3. So we can actually simplify that. This is called combining like terms. Each of these terms are alike, so we're going to combine them. So we have 8 husks plus 3 H's. 8 plus 3H, and that would give us our total amount of husks, but we can't solve it. We don't have enough information. Okay, let's see how the book has done it now. We've got 2 different things going on here. We've got to model it with algebra tiles. Now, algebra tiles, if we were in class together, we'd be using our algebra tiles. I love algebra tiles. But the little square ones represent 1. 1, 2, 3, 4, 5, 6, 7, 8. Those are the 8 husks. The long ones, they just happen to be long. This is just the shape they happen to be. These represent the variable. So in this case, we use the variable of H. So each of these is an H. And that's just the way algebra tiles work, where the little squares each represent 1, and the long pieces represent the variable, the X, the H, the, whatever. So that's how they've laid it out. We have 8 plus 3 unknowns. These are the unknowns. Unknowns. Okay. Or you could use words. The second model is just using words without the algebra tiles. Describe how to find the total number of corn husks. Add the number of corn husks the Ramirez family has to the number of husks in the 3 bags Isabel brings. So they've just written out as the number they have plus 3 times the number in 1 bag. And I don't know how much this is, so we would use H for that. That looks delicious. Okay, number 1, look at the algebra tiles in the first model. Let's go back to the first model with the algebra tiles. What do the small squares represent? Oops, I already told you. Spoiler alert. Small squares represent 1 husk each. What unknown quantity does each large rectangle represent? So each large rectangles represent the bags with the unknown amount. Okay, number 2 here says, use the variable x to represent each large rectangular tile. So that now they're going to use x instead of h. Fine, be that way, be boring. What algebraic expression can you write to represent the situation? Well, how many do we have? We have 8 husks. And we have how many bags? We have 3 bags. And how many husks per bag? We don't know. So we're going to use x. X means I don't know. And then to find how many altogether, you know altogether. That one you've learned since 1st grade. Altogether means add. So 8 plus 3 bags, 3x. Number 3, Gavin looks at the second model and uses the variable h. See, Gavin's more creative. H for husk, for goodness sakes. Gavin looks at the second model and uses the variable h to write the expression 8 plus 3 h's. How many terms does the expression have? Which term is a product? Identify the variable and the coefficient and explain what each represents. Ooh, so now we're getting deep into the algebra vocabulary. Let's think about this. So, the terms are how many, separate thingies are in the expression. I give them another name, but the name is already termed. So, here is the first term, and here is the second term. And they are not alike, so they're separate terms, because 8 and 3 h's are totally different things. We don't know, it's 3 of we don't know what. We don't know how many. So, there are 2 terms. 2 terms. That answers our first question. How many terms does the expression have? So we finished that question. Now, which term is a product? And you should remember from your vocabulary, product means the answer to a multiplication problem. So it's asking what in here is multiplication. Well, we know 8's not multiplication. That's just 8. 3 x's, that's multiplication. That's 3 times x. X plus x plus x. That's repeated addition, as you know from 3rd grade, from learning about multiplication. That's 3 x's. So that's the product. 3x is, I'll put a, is a product. Okay, now we need to identify the variable. I know you know what a variable is, but do you know what a coefficient is? So the variable, as you know, is x. I'll even put over here 3, let's put this bigger, 3x, where this is the coefficient, this is the variable, and what do they represent? Well, the coefficient in this case represents how many bags. And the variable represents how many husks per bag. So number of husks per bag. And that's why it's a variable, because we don't know. They did not tell us. Now, Jade is going to try to figure this out. So Jade writes the expression for the total number of husks as 3c plus 8. Then Elias gets in on the game, and Elias writes it as 8 plus c plus c plus c. Are both expressions correct? So let's see. Let's look at our past answers and see. Is 3c, they just decide, I don't know why they decided to use c. Corn? C for corn? Right, fine, whatever, guys. 3c, that's the same as 3h, right? And then the 8, so they just flip the order. So that works, right? We can flip the order in addition problems because of the commutative property. Thank you. I know you got that right. It's fine. I know you got it right. Commutative property says that in addition you can flip the order. So that one works. And then Elias, instead of writing 3 C's, he just wrote the 3 C's spaced out. He did repeated addition, which, as you know, because you passed third grade already, is multiplication just written out. So they are both correct. And now that we've explained why they're correct, now we have to put it on the paper. How do we want to explain that on the paper? Well, adding the variable 3 times is the same as multiplying it by 3. And then as far as flipping the order, you can add in any order because of the commutative property. That's an excellent answer. We did a good job. I think we need a gold star. Gold star on that answer. Hooray! Okay, number 5. How can you write an algebraic expression to represent a situation in which in which there is an unknown quantity? So this is a more general question of just how can you write an algebraic expression to represent a situation in which there is an unknown quantity? Okay, that's one of those things that it's more of a discussion. How do we put it down on the paper? Let's think about it. Well, what did they do up in their model-its? The first one, they drew it with algebra tiles, but they drew it. They illustrated it. They used a model. There we go. They modeled it, they used a model. So you can use a model, or you can describe it. Okay. Did I move that down? Oops. Hang on. Okay. You can use a model to figure out the numbers and operations to use, or you can describe it in words. And then you can use a letter to represent the number you don't know. So for example, to give a very, very basic example, we can put, for example, 2 plus 1. Oh, I don't know what that is, so I could put x. That's the thing we don't know. You can probably figure it out, but you know what I mean. Okay, now the reflection is for you to do. Think about the model and strategy you've discussed today. Basically, which do you prefer? Do you prefer modeling it with the algebra tiles, or do you prefer writing out what it is and thinking about it that way? So go ahead and pause, put that answer, and tell me what you think. Okay, hopefully you paused and gave me your answer, because we are going to do 3 practice problems together before you do your green pages. And now, are we on bagels now? Oh, I love bagels too. Man, this book is killing me. Gaspar writes the algebraic expression 5b, that's 5 B's, not 5, it's not 5, it's 5 B's. Five things we don't know. 5 bagels, I guess. I'm assuming B's bagels. Plus 3.79. It represents the total cost in dollars of buying 5 bagels and a container of cream cheese. Identify any variables, coefficients, and terms in the expression. Tell what each represents. Okay, so we've got 5 B's, and oh, look what here, it says 5 bagels. I wonder what it could be. And then it says 3.79, and oh look, a container of cream cheese. So there are 2 terms here. And how do we want to write this down? I guess let's just put the expression down here and label it, huh? Seems easiest. 5b plus 3.79. There are 2 terms. This is term 2, and that's cost of cream cheese. And this is term 1. And that is the cost of the 5 bagels. We do not know the cost of a bagel. So this is the cost of 1 bagel. And we have to multiply by 5 to get 5 bagels. We also need to put in here, this is the variable. And this is the coefficient. There we go. Did we get all the things? Yes, we got all the things. Good for us. Okay, number 8 then. No pictures. Psh. Let's see, is it about food? No, no food? Whatever. Write an algebraic expression for the word phrase below. Which factor of your expression is a sum, remember that's addition, of 2 terms? Okay, so it's telling us the product, so that's multiplication of 5.8 and the sum of 9 and a number, which we don't know, so we're going to call it n. Okay, so it says the sum, I'm gonna work from the end over here. So the sum of 9 and a number. So the sum of 9 and a number. Add them together. That's what a sum is. And we wanted the product of that. So if we wanted the product of that, we need to multiply, but we can't multiply by just one of them. That wouldn't work. That would be multiplying, that would be the product of 5.8 and 9, and then the sum of a number. So I'm going to take off that multiplication sign. You can leave it, it's fine. I'm going to put parentheses around this to make sure that we know that the 9 and the n need to stay together. It's the sum of n and a number. They need to stay together. And then I'm going to multiply that by the 5.8. So I'm going to put that outside the parentheses. Having a multiplication sign right there would be fine. But you don't need it because when a number is touching the parentheses, that already means multiply. Okay. Try it again with part B. Write an algebraic expression for the word phrase below. Oh, which factor of the expression is the sum of 2 terms? I forgot to answer that part, didn't I? Which factor of your expression is the sum of 2 terms? And that would be this part. There we go, creative answering. Okay, and then this one, we're writing an algebraic expression. And it says, is your expression a difference or a quotient? And explain it. So it says, subtract a number from x. Subtract a number x. Okay, so subtract x from 15. Subtract x from 15. And then divide by 2. Okay, well, there's a few ways to write this. Remember, because of PEMDAS, I can't just put divide by 2 because divide comes before subtract. So I would have to be doing this first. I can't do that. I need to keep these together to make sure they're done first. I need to make sure the parentheses come first. Another way you could write this would be 15 minus x and then divide by 2. Both of those are really good ways to write it. Either of those work. Okay, now is your expression a difference or a quotient? So, what's the last step we do? That would make the answer. Difference, remember, difference means subtract. Quotient means the answer to division problem. And we are doing both, but we're doing the subtraction first and then the division. So, division, because the answer is the result of division. Or it will be if we could solve it, but we don't have enough information to solve it. So the answer would be the result of division. There we go, and a little bunny rabbit to celebrate. There we go. Last one, Laketta has a $50 gift card for an online music store. Who uses those anymore? Online music store. Do we use those anymore? I don't. Anyway, each song costs S dollars, so we don't know how many dollars it costs for a song. Write an algebraic expression that represents the amount left on the card after Laketta buys 7 songs and show your work. Okay. Well, she wants to buy 7 songs and we don't know how much each costs. So 7 songs times whatever they cost. Okay. And then how much does she have? She has 50. but she's spending money. If she's spending money, then the money is going away. How can we represent going away? Subtraction. Okay, so think it through one step at a time. Put down what you know, and then it kind of works itself out from there if you're careful and thoughtful about it. So that is it for that lesson with me. Go ahead and do your green pages and let me know if you need anything.